there's two electromagnetic fields there, and it's and they're opposing each other, so it causes the movement. That's what causes the movement of the magnet on the pivot of the cell.
As they explain, they show their thinking as it develops. Here, initially, the use of terms was inaccurate. Some errors are trivial, others reveal fundamental misconceptions. How then to intervene in ways which build on the understanding that is emerging?
As you can see, like when there's around a conductor, the direction of magnetic field is going round and round.
The right-hand screw?
Yeah, right-hand screw rule. So since the field is going around, that shows the direction the magnet will spin as well.
And as magnetic fields can't cross, one's pushing it, as one of the fields from the cap away here is pushing this electric field the other way. Right. And depending on if it's north or south, depending on what direction the
movement goes.
Yeah, the nail moves.
Now, when you get the ideas going, can we just jot notes down on here?
Yep.
So that we can see the way in which you're thinking?
It was on the positive end, now, wasn't it? Yeah. Brilliant.
No, you can.
I think it's important that we got the explanations at the end, because they're having to recall it, they're having to explain to one another what they understand by this. But we need them to have a copy of it. We've got to concentrate on students getting an output from their learning.
They'll probably learn more from doing practically than someone writing it on the board and telling me, well, this is the way to do it, because I probably wouldn't have understood it, and knowing me, I probably wouldn't have asked neither. I just said, OK then.
The diagrams which learners drew gave just a partial view of their understanding and indicate which aspects cause most or least confusion. In response, these teachers and trainers began to look at different ways of helping learners to clarify their ideas. Here, devising tasks which encourage learners to think about and use the principles of magnetic fields, looking especially at the magnetic fields around currents in wires. It's about helping learners make connections between what they already know and finding out where their areas of confusion are, and supporting learners to sort these out.
These ideas have got to be practical based rather than, oh, draw this. Again, if we look at D, reinforcing the idea that the coil it amplifies the effect of the one conductor. Well, okay then, let's give them a length of conductor and let them generate their own coil.
The teachers and trainers in this sequence are on a journey of professional development. They have been willing to share their reflective practice with you to provoke further thinking and discussion on approaches which reveal and develop learners' understanding. You may also wish to refer to sections in the accompanying teacher and trainer resource. Using moments is often intuitive. We can feel the forces involved. Explaining the effects in terms of basic principles requires a range of experiences. Activities were developed by teachers and trainers to engage learners in understanding how things move in terms of moments and how they balance.
We could easily use a bicycle wheel and make the most of the spokes and turn it into very much more a hands-on.
The activities were then tested with learners.
Just take it.
Like all activities in this project, they can be used to support learning outcomes at different levels. But learners bring prior knowledge, perceptions and confusions to the activity, especially when words like moment, force and talk are used informally in everyday speech. But how to take account of their prior understanding?
Write down 5 examples, excluding the tap, of something that you did this morning where a force exerted a turning effect. 5 examples. Take a minute to do this.
Ivan and learners agreed to be filmed to help think about how teachers and trainers could capture and make use of learners' prior understanding in practical classroom situations.
We were told we had to come up with 5 things that we did this morning that had to do with the turning motion, like, you know, turning a tap or turning a door handle, and we had to write them down.
We thought about it for a bit because a lot of it was subconscious, but then you start to think about, you know, like turning on taps and like penning a bike and stuff.
I gave them the tap and I automatically thought, well, everybody turned the tap on this morning, and therefore I was expecting that connectivity to go to other things.
Milk bottle tapping. You twist some milk bottle tap.
He didn't say, like, in what sense he meant, like, he said like a force. He didn't say whether it was like, whether like, you know, pushing a button or riding a bike or something.